Hello everybody, welcome into the last lesson of Algebra 1. Let me congratulate you on making it this far. You've done very well if you've made it this far. I have no doubt as you progress into the higher level maths you're going to do just fine. So if you're using this for high school, for a college, or to get your GED or anything like that, kudos to you. I'm sure you're going to do just fine. And big disclaimer, I always like to say I am not a replacement for your teacher. I'm only here as a supplement and to help you. So always follow what your teacher's telling you first. But today we're basically going to review methods of solving quadratic equations. The goal of today is I'm going to put a quadratic equation up here and we're going to go over the best possible method to solve that particular equation. By now we have learned 4 methods for solving quadratic equations, which that's pretty much all of them. The 5th one's graphically using a graphing calculator, but I'm not going to get into that one. That's something you'd want to see your teacher for, because it's kind of a little hard for me to put that up on screen. I don't have a clue how to do that, so it's best we do the hand methods here, the methods that go by hand. But the first lesson we've learned, and probably the easiest one, is if you have perfect squares on both sides of the quadratic equation. You could always argue the right side would have a perfect square no matter what, sure. But if this only applies, are both sides of the quadratic equation perfect squares? And then we've talked about factoring quadratic equations. So that we've spent quite a bit of time on factoring them earlier in the course. And then more recently we talked about completing the square as a method of solving quadratic equations. And then even more recently than that, we spent 2 lessons on the quadratic formula, how to solve the equation using the quadratic formula. Now, this list, which before I go further, let me say, if you're struggling with any one of these, there's no shame in that. Just please see my previous videos on how to do these things. They will all be within the course here throughout the Algebra 1 playlist. Feel free to watch them. They're free. They always will be. I'm going to leave them up there forever. So my goal is to help people for free because I love math. I love helping people. So they're always going to be there. But when you're given a quadratic equation, because once you get to geometry in Algebra 2, you're going to have some quadratic equations, and it's not going to tell you by which method to solve it. You're going to have to be able to pick out a method to solve it. Well, there's a good order to work in, which you don't have to follow this order, but there's a general consensus on what's the easiest way to start. The first method, if both sides of the quadratic equation are perfect squares, then proceed with that. That's always the easiest. If that's not possible, then your next one's factoring it. Try to factor the quadratic equation. And if factoring's not possible, then next try it by completing the square. Now, completing the square and the quadratic formula, both of those will work on any quadratic equation. Unlike the first 2, the bottom 2 will work on any quadratic equation. But in general, if completing the square is going to cause you to have fractions, you probably don't want to use it because then it gets messy. I mean, you can use it if you want to deal with fractions, but why torture yourself like that? If that's the case, then you should probably just move on to using the quadratic formula. You'd be better off using the quadratic formula at that point. So those are the 4 methods we have learned for dealing with quadratic equations. Alright, so let's throw up some examples here. Say I have something like 5x squared plus 19x equals 4. Okay, so 5x squared plus 19x equals 4. Well, definitely the right side's a perfect square, but the left side's clearly not a perfect square, right? Okay, well, there goes the perfect square method. That's out the window. How about factoring? Well, if we want to attempt to factor this, That means we need to get rid of the 4 out of the right-hand side, make the right-hand side equal to 0. So you would subtract 4 from both sides. And if we did that, you would get 5x squared plus 19x minus 4 would be equal to 0. Now that we've set it into a form where we can potentially factor it, I'm not going to say yet that we can. Can we potentially factor this? Well, let's take some factors of 1 and let's take some factors of 5, which the only ones are 1 and 5. 4, you have 1 and 4. Then you also have 2 and 2. Those are factors of 4. Well, 5 times 2 would give you 10. Then plus 2, that would give you 12, or minus 2 would give you 8. So it's clear that 2 and 2 are not viable factors of 4. But what about 1 and 4? What if I multiplied 5 by 4 and then 1 by 1? You'd be dealing with 20 and then 1, which would give you that 19 in the middle. So your factors would be x, we'll deal with the other one in a second, x and 5x for sure, because those 1 and 5, if you remember, are your coefficients on the 5x squared, the factors of that. Now this here shows 5 is times 4, so 4 is going to go in the left parenthesis, and then 1's going to go in your right parenthesis. Now which one's plus, which one's minus? That's what we have to determine. Let's FOIL this back out. X times 5x would give you 5x squared. How about, let's see, we do a minus 1 here and then a plus 4. Let's see how that works out for us. So 5x squared, then we have minus x plus 20x. Well, what do you know? That gives you plus 19x, and then 4 times negative 1 gives you negative 4. So yes, we have completely factored this. It turns out we can solve this particular equation by factoring, which is great. Now all you got to do is set each of the factors equal to 0, solve for x. So x plus 4 equals 0 would simply give you x equals negative 4. And then 5x minus 1 equals 0 would simply give you 5x equals 1, which means x would equal 1/5. So your two answers to this are going to be x equals both negative 4 and positive 1/5. That would be your answer to this particular quadratic equation. X equals negative 4 and then positive 1/5. And we were able to determine that by factoring. So I know it's been a little bit since we talked about factoring, but in actuality, in Algebra 2, a lot of your problems are going to be solved by factoring. So I cannot emphasize this enough. If you're not comfortable with factoring, please go back and watch my previous videos about factoring. It's really going to help you in the future. Okay, next one. How about x squared minus 8x equals 11? So we have x squared minus 8x equals 11. Well, we could argue the right side's a perfect square. It always is. It would just be the square root of 11 squared, right? But the left side's definitely not a perfect square. So we can throw out the perfect square method. That goes out the window. Next, let's attempt factoring. If I'm going to attempt factoring, I have to make the right-hand side equal to 0, which means I need to subtract 11 from both sides. If I do that, I would get x squared minus 8x minus 11 would be equal to 0. I think it's clear to see that this is definitely not going to factor, because there's no factors of 11 besides 1 and 11. No factors that's going to make a middle term of negative 8. It's just not going to happen. So we can throw out factoring. However, there is the third method of completing the square. We can actually proceed with that on this. So in order to do that, we'll have x squared minus the 8x. Now you take half of negative 8. So you're going to add that, take half of negative 8, which is going to be negative 4. You'll raise that negative 4 to the second power. Then you have to do the same thing to the right-hand side, add that negative 4 to the second power. Well, let's see, this would turn into x squared minus 8x plus 16 is equal to 11 plus 16. Okay. Well, what do you know? X squared minus 8x plus 16 is a perfect square trinomial. It factors into the quantity of x minus 4 squared. That's going to be equal to your right-hand side of 11 plus 16, which turns out to be 27. Now we actually have perfect squares on both sides. So we can proceed with that method now since we've completed the square. Alright, so square root of both sides, that'll give you x minus 4 on the left. That'd be equal to both plus and minus the square root of 27 on the right. Which we know the square root of 27 does break down further. It breaks down into the square root of 9 times the square root of 3. Which means then x minus 4 is equal to both plus and minus 3 times the square root of 3. So therefore x would equal 4 plus and minus 3 times the square root of 3. And that would be your answer, or I should say answers, because there's actually two answers since you have both plus and minus that. So x equals 4 plus and minus 3 times the square root of 3. So that one was nice enough we could solve it by completing the square. I mean, at this point, I really have nothing new to teach you. It's just a great review. And so you get used to seeing quadratic equations and you know for yourself which method's going to work. The methods I use today, I'm not saying you have to do a particular problem with that method, but I'm showing you some, because some people make the mistake, they want to jump right to quadratic formula. And as we saw from the lessons I taught, that could be a real pain in the butt sometimes. Don't do that to yourself if you don't have to. Alright, next one. We have 3x squared equals 2x plus 7. So we've been given 3x squared equals 2x plus 7. Well, the left side's a perfect square, but the right side's clearly not. We could throw that out the window. There's no perfect square. What about trying to factor this? Well, that means we have to make the right side equal to 0, so we have to subtract 2x and 7 from both sides. If we do that, you'll get 3x squared minus 2x minus 7 equals 0. But let's take a look at this. Can we factor this? Well, your only factors are going to, of 3 are 1 and 3, and your only factors of 7 are 1 and 7. Nothing about those is going to give you a middle coefficient of -2. There goes your factoring. So next we move on to completing the square. Well, already we need that coefficient of x squared to be 1. So we'd have to divide the entire thing by 3, and then you're dealing with fractions. So completing the square is not ideal. So we have no choice but to do the quadratic formula, which I'm going to put that up here real quick. X equals negative of b plus and minus the square root of b squared minus 4ac all over 2a, right? There's the quadratic formula, which is not a pretty formula, but it does work. So now I need to solve for x here. X, let's see, we'll take the negative of the b coefficient. Well, b is -2, so -2, that's +2. That'd be both plus and minus the square root of the b squared, which that'd be -2 to the second power, minus 4 times the a, which is 3, times your c, which is -7. This is all going to be over 2 times a, which would be 2 times 3. Yeah, that was a fun one. You see why we don't want to just jump to quadratic formula if we don't have to. Okay, so This will break down into 2 plus and minus the square root of, let's see, negative 2 squared is positive 4. Negative 4 times 3 is negative 12 times negative 7. That's positive 84. This will all be over 2 times 3, which is 6. So now we have 2 plus and minus the square root of 4 plus 84 all over 6. Well, what we have to do now, let's take this a step further here. This would break down into 2 plus and minus the square root of 88 all over 6, which is still not looking very nice. But we know the square root of 88 will break down. I'm going to move this up here. We'll have 2 plus and minus. See, you'll have the square root of 4 times the square root of 22. This will all be over 6, which we know the square root of 4 happens to be 2. So this turns into 2 plus and minus 2 times the square root of 22 all over 6. And we know between the 2, and the 6, you have a common factor of 2 that'll factor out of each one. So divide the first term by 2, you just get 1. That'll be plus and minus. 2 times the square root of 22 divided by 2 is simply the square root of 22. All over your denominator of 6 divided by 2 is 3. So the x value for this particular one, or I should say values, x is equal to 1 plus and minus the square root of 22 over 3. So yes, I think you see why we don't always want to jump to the quadratic formula first. It's a lot more work than you need to do for some of these problems. But unfortunately, with this particular problem, we really had no choice. Unfortunately. Okay. What's next? Alright, let's see. We have 2x squared all over 3 plus 3x all over 4 is equal to 1. So we have some fractions thrown in. Well, the least common denominator of 3 and 4 is what? It's 12. I mean, yeah, right side's a perfect square, but the left side's clearly not, so there goes that. Before we can even think about factoring or even think about anything else, we need to get rid of these denominators. So the least common multiple of 3 and 4 is 12, so now you want to multiply both sides by 12. We'll multiply both sides by 12. This would give you, for the first expression, 4 times 2x squared plus 3 times 3x, well, that would equal 12. So now we at least have this in a way that we got rid of the fractions, which this would turn into 8x squared plus 9x equals 12. Okay? Well, before we could think about factoring, we need to make the right side equal to 0, so we have to subtract 12 from both sides. Let's go ahead and do that here. We'll have 8x squared plus 9x minus 12 equal to 0. Alright, let's attempt to factor this. Factors of 8 are going to be 1 and 8, and then we have 2 and 4. That's about it for 8. How about 12? You have 1 and 12. You have 2 and 6, and then you also have 3 and 4. Those are factors of 12. Okay, let's take a real look at this here. Let's take this one at a time. How about 1 and 8 and then 1 and 12? Okay, let's see here. What if that worked? No, it wouldn't work, because even if 1 and 12, you're either going to get something with 72 or you're going to get something with 20. And that's not going to give you a middle coefficient of 9. That doesn't work. All right, how about, let's see, 1 and 8 and 2 and 6. Looking at those don't work. How about 1 and 8 and 3 and 4? Definitely not going to work. So there goes your 1 and 8. None of those are going to work. So how about 2 and 4 and 1 and 12? I don't think that's going to work either, because you would have 48 and stuff as your middle coefficient. That's not going to work. All right, 2 and 4 and 2 and 6. How about that? Would those work? 8 and 12 would be. I wonder something here. Let me see, because sometimes factoring's a bit of trial and error. I do 2x times 4x. Alright, let's see. So what if I did 8, 12. So this would give me 2 times 6, which would be 4 times 2. Okay, so let's see. 8x squared plus 12, let's see, plus 12x minus 8x. That would be minus 4, no? Let's see. Nope, those aren't going to work. Okay, it was a nice try. Sometimes factoring is not always the best either, especially when you have multiple factors of each. The only real possibility left is 2 and 4 and 3 and 4. Well, 4 times 3 is 12. Even if I subtracted 8 from that, I would get 4. So how about 4 times 4 is 16. So even if I subtracted 6 from that, I would get 9. I would get 10. So no, this doesn't factor, unfortunately. So unfortunately, we have a problem that just isn't going to factor. Okay, and completing the squares really not looking all that great either, because you would have to divide everything by 8 to get that coefficient on the x squared equal to 1, which would give you fractions. So completing the square is definitely not the way to go with this. So we have no choice but to do the quadratic formula, which I'm going to put up here again. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So there's the formula. So let's go ahead and start working this. X would equal, all right, the negative of b. Well, b is positive 9, so that would give you negative 9 for negative b, plus and minus the square root of, let's see, b squared, so that would be 9 squared, minus 4 times your a coefficient of 8, times your c coefficient of negative 12. This would be all over 2 times your a, which is 8, so 2 times 8. So yeah, we just set up a pretty hideous problem here, which means that x is going to equal negative 9 plus and minus the square root of 9 squared is 81. All right. So now we need to figure out negative 4 times 8 is negative 32 times negative 12. 32 times 12, that's going to give you 384. So you'd have 81 plus 384 all over 2 times 8, which is simply 16. Which means I'm going to move this over here now. You'll have x is equal to negative 9 plus and minus the square root of, let's see, 81 plus 384 is 465 all over 16, which this begs the question, Can the square root of 465 factor any further? Let's see here. No, it doesn't. There's no perfect factors. Not even any of the factors are perfect squares. So this is literally going to be your answer, is x is going to equal -9 plus and minus the square root of 465 over 16. This won't reduce any further. So that was an ugly problem. And some of these can be ugly. So as you head into further higher maths, you have to be prepared for that real possibility. You're going to deal with some ugly problems. Alright, here's another one. We have y plus 3, that quantity squared, all over 4 is equal to 5. Well, I think before we do anything, we want to get rid of that denominator of 4, don't we? So we want to multiply both sides by 4. If you do that, you'll end up getting y plus 3, that quantity squared, is equal to 20. I think it's obvious that both sides are perfect squares now, so we can deal with that method. We don't have to deal with the quadratic formula or completing the square or factoring or anything on this one. So the quantity of y plus 3 squared equals 20. Take the square root of both sides, you'll get y plus 3 is equal to both plus and minus the square root of 20, which means then that y plus 3, that's going to equal plus and minus the square root of 4 times the square root of 5, which means that y plus 3 equals plus and minus 2 times the square root of 5. So then for your final answer, y would equal -3 plus and minus 2 times the square root of 5. So we were able to do this by perfect squares. Y equals -3 plus and minus 2 times the square root of 5. That would be your answer. I should have just 1 to 2 more. 1 to 2 more. Okay, what do we have here? We got, I'm going to do 2 more. So we have 1 over 3x is equal to 2x minus 3 all over 2. So we have 1 over 3x is equal to 2x minus 3 over 2. So we're getting practice with some proportions. If we recall from our proportions unit, whenever you have algebraic proportions, we need to exclude any values of x that will give you an undefined result. So if we set that denominator of 3x equal to 0, I think it goes without saying x would give you 0. X would be 0 for that. And if x equals 0, you have 1 over 0, makes the whole thing undefined because you can't divide by 0. So we need to put the condition at the top right that x does not equal 0. If we get that as one of our solutions, we have to throw it out because that'll make it undefined. So now let's do some cross multiplying here to solve this proportion. You can take 3x times the quantity of 2x minus 3. You'll set that equal to 1 times 2, which is 2. well, we don't know what form it's going to take just yet, but let's do some distribution. 3x times 2x, that's 6x squared. Then 3x times negative 3, well, that'd be minus 9x. That would equal 2. Well, now we have a problem we can work with. 6x squared minus 9x equals 2. Okay. What do we got here? Well, the right side's a perfect square, but the left is definitely not. So there goes your perfect square method. How about factoring? Well, that means we gotta subtract 2 from both sides to make the right-hand side equal to 0, so let's do that. You would get 6x squared minus 9x minus 2 would equal 0. Now let's see if any of these factors will give you a middle coefficient of negative 9. Of course, for 6 you have 1 and 6, and then you have 2 and 3. For 2, well, all you have is 1 and 2. Okay, let's see. 6 and 8, no, that's not going to work. 12 and 1, nope. So 1 and 6 and 1 and 2 don't work. I mean, I could do it and show you, but it would take forever. So sometimes factoring's trial and error, as I said. Okay, how about 2 and 3 and then 1 and 2? 2 is 4, 3, no, that's not going to work. 6 and 2, that'd be 8, or yeah. Okay, so this isn't factorable, unfortunately. This is not a factorable equation. And to be quite frank, this would not be a good candidate for completing the square either, because you would need to make that coefficient on the x squared term a 1, which means you got to divide everything by 6, giving you fractions. So let's deal with the quadratic formula. X would equal negative b plus and minus the square root of b squared minus 4ac all over 2a. So there's your quadratic formula. Now let's go ahead and start plugging in the values. X is going to equal, so b is negative 9, so negative 9, that's positive 9, plus and minus the square root of your b squared, that's going to be negative 9 to the second power, minus 4 times your a coefficient of 6 times your c coefficient of negative 2. All over 2a, well, your a coefficient is 6, so this would be over 2 times 6. Okay. So we've set up our quadratic step. Now let's go a little further with breaking this down. X would equal 9 plus and minus the square root of, okay, negative 9 to the second, that's positive 81. Negative 4 times 6, that's negative 24. Times negative 2 turns into positive 48. This is going to be all over 2 times 6, which is 12. So now we have 9 plus and minus the square root of 81 plus 48 all over 12. Well, that's going to be equal to 9 plus and minus the square root of 129 all over 12. Now, what I need to determine, are there any factors of 129 that are a perfect square? Well, let's find out. No, not that. Not that. Well, looks like none of the factors are a perfect square. So that means for your end result, x equals 9 plus and minus the square root of 129 all over 12. So, and that's really as far as we can break it down. So x equals 9 plus and minus the square root of 129 over 12. And we didn't get 0, so that's good. We can keep both solutions then. I got one more problem, then we're done. Okay. We have 4x minus 3 all over 2x minus 3 is equal to 5x minus 3 all over x plus 1. Yeah, we have a double ratio, don't we? Well, that's a double, we have a proportion, and both denominators have variables. So what we need to do now is simply set both of these denominators equal to 0 to figure out what values of x are not acceptable. So 2x minus 3 equals 0, right? Which means 2x equals 3, which means x would equal 3 halves. So if x equals 3 halves, that makes this denominator 0, which would make the expression undefined. So it's clear that x is not allowed to equal 3 halves. It can't equal that. Well, what about the other denominator, x plus 1? We don't even got to really do much. We know x equaling negative 1 would make this denominator 0, which would make the expression undefined. So x can also not equal negative 1. So as long as we don't get 3 halves or negative 1, we're good. If we get either of those values, we have to discard the solution or solutions. So now that we've established those perimeters, let's go ahead and cross multiply. You'll end up having 4x minus 3 times the quantity of x plus 1. That's going to be equal to the quantity of 2x minus 3 times 5x minus 3. Holy moly, a lot of foiling, huh? Let's FOIL this. So you would end up getting 4x squared plus 4x minus 3x minus 3 would be equal to 2x times 5x, that's 10x squared. 2x times negative 3, that'd be minus 6x. Negative 3 times 5x, that's minus 15x. And negative 3 times negative 3, that's positive 9. So yeah, this just turned into a very long problem, didn't it? So the left side, let's simplify a bit. You'll end up getting 4x squared. 4x minus 3x, so that'd be plus x minus 3 is going to be equal to, let's see, 10x squared. Negative 6x minus 15x, that'd be minus 21x, then plus 9. Well, let's see now. So, if we take 4x squared minus 10x squared, because ultimately we want to make the right side equal 0, don't we? We can make the right side equal 0. We need to subtract 10x squared from both sides. So if we do that, you'll get negative 6x squared. And then if you add 21x to both sides, you'll get plus 22x. Then if you subtract 9 from both sides, you'll get minus 12. That would all equal 0. So now we got it down to negative 6x squared plus 22x minus 12 equals 0. Well, we can definitely divide the whole thing by a negative to get rid of the negative coefficient on the front of this, which we don't have to, but it's going to make life easier if we don't have to deal with negatives as much. So negative 6, so let's see, we also have common factors of 2 on each term, so we're actually going to divide by negative 2. If you divide negative 6 by negative 2, you'll get positive 3, so you would get 3x squared. Then divide your positive 22 by negative 2, you'll end up getting minus 11x. Then divide negative 12 by negative 2, you would get positive 6. So now what you got is 3x squared minus 11x plus 6 equals 0. Now, do any of these factor? Let's hope and pray they do. 1 and 3 are the only factors of 3. 6, you have 1 and 6, and then 2 and 3. Oh, I think we got something here. If we do 3 times 3 and 1 times 2, yes. Okay, so this will factor into, let's see, x, then you'll have 3x. Then we said 3 was times 3, so that's going to go here. And then 1 was times 2. Okay, so let's see, 3x squared minus 2x minus 9x. Yep, that would give you negative 11x. Negative 3 times 2. That's going to give you positive 6. So we actually were able to factor this. No quadratic formula. So now you just have the quantity of x minus 3 times 3x minus 2. Well, set each factor equal to 0, x minus 3 equal to 0, that's just going to give you x equals 3. And then, so that's one solution. And 3 is not a prohibited solution, so that's a viable solution to this. Now, what about 3x minus 2 equal to 0? Well, that would just end up giving you x equals 2/3. So, and 2/3 is also not a prohibited solution, so you got two solutions of x equals 3 and x equals 2/3. And that's really it for this. So, basically now, that's the end of Algebra 1. We have covered Algebra 1 completely, so congratulations for making it this far. So stay tuned for my Welcome to Geometry video. Next lesson we are starting geometry, which is completely different from this. So I hope everyone has a good night. Take care.